This is a walkthrough of Maths Paper 1, June 2018 for Edexcel. Let's get started. For question 1, this is a small angled approximation question, and it says when theta is small and measured in radians, use a small angle approximations. So whenever we're working in terms of equations, graphical equations or differentiation or anything like that, you're always going to be working in terms of radians. Okay, so when x is small for sine theta, it is approximately x. And the reason why that works is because if we draw our sine graph here, you can see that at the start, when your x value is really, really small, like close to 0, you can see that this is kind of a y equals x line. And something very, very similar with our cos graph should probably look something like this. Okay, cos theta or cos x would be approximately 1 minus theta squared over 2, which is when your x value is small. And you can see that at the small value here, your quadratic will kind of look like that. But at small values, it would again be very, very similar. At bigger values of x, you can see they start to diverge and start to kind of look different from the graph itself, but this only applies when x is small. Okay, so we're going to use these but these graphical things aren't really necessary, but we're going to use these identities to kind of help work this out. So I'm going to rewrite this, but we're going to substitute everything in. So I have 1 minus, and I'm going to put brackets. Now cos 4 theta here, we know that cos x is equal to, or this should be x, sorry, I don't know why I put theta there, 1 minus x squared all over 2. I'm going to put 1 minus, well, I've got 4 theta here, so instead of x, I'm going to put 4 theta all squared, kind of like your functions, when we're putting in numbers in our functions, divided by, now on our denominator, well, I'm going to leave 2 theta the same, because it's just 2 theta. Now sine 3 theta here, we're going to use this identity, so we end up with just times by 3 theta. Cool, let's start to simplify some stuff. So we end up with 1 minus 1 plus, well, 4 theta all squared would give us 16 theta squared, divided by 2. All divided by, well, this is going to give us 6 theta squared. This gives us the following: 8 theta squared over 6 theta squared, which is just going to be 4 over 3. Cool. Next question. A curve C has this equation, and we want to work out dy by dx. Okay. First thing I'm going to do is convert everything into index form. So I end up with y is equal to x squared minus 2x minus 24x to the half. And then we can just differentiate like normal. So that means that dy by dx for part A will give us 2x minus 2. 24 times by a half gives us minus 12. X, we're going to subtract 1 from the power, so that gives us minus 1 over 2, and that's going to be your answer for part A. Part B, well, we're just differentiating this again, so that means that d2y over dx squared is going to give us 2, because 2x differentiates to 2. This will just differentiate to nothing. We're going to again differentiate the following, so minus 12 times by minus a half will give you positive 6, and then we're going to subtract 1 from the power, which gives you minus 3 over 2. When it says verify for part B here, essentially what we're doing is just taking whatever information they're giving to us and just substituting into some sort of equation. In this case, we're substituting into a dy by dx. Why? Because we're going to try to prove that when x is equal to 4, we should end up with dy by dx should equal to 0, because that's a stationary point. So I'm going to sub in x equals 4 for, this is obviously part I even, part B, 4 dy by dx when x is equal to 4. So we end up with 2 times by 4, so I'm just substituting it into this equation here. Minus 2, minus 12, 4 to the minus a half. And you could probably put this into your calculator directly even, but because it's 2 marks, we might need a bit of proof that there's a bit of expansion. But we can just quickly do this, and we can probably put this into a calculator directly. But we know because it says verify stationary point, this is going to equal to 0 anyways. We can make that assumption. This is 8 minus 2, which is 6. So this should be minus 6 as well, which should equal to 0 in your calculator. Therefore, if dy by dx is equal to 0, therefore it's a stationary point. Cool. At x equals 4. Alright. Part C. Determine the nature of the stationary point, giving a reason for your answer. Okay, so it's helped us, in part A, we've worked out d2y by dx squared. So we're going to substitute this x equals 4 into our d2y by dx squared. And that will tell us if it's a minimum point or if it's a maximum point. We're going to substitute x equals 4 into our d2 by dx, d2y over dx squared. And I'm just going to put that into the calculator. And this gives us, it's disappeared. There we go. 4 to the minus 3 over 2. And this gives us 2.75, which you can see is bigger than 0. If it's bigger than 0, therefore it must be a minimum point. The way I kind of remember it is that if it's a positive number, the next gradient will be tending towards positive. So that must be a minimum point. And if it's a negative number, that means our next gradient should be going towards negative. So that means that would be a maximum point. So if less than 0 is a max, bigger than 0 is a minimum. Okay, that's kind of how I remember it. But if there's any other way that you guys remember it, definitely just put it into the comments and let me know. Okay, question 3. We've got a sectors question and using radians. So we will be using potentially these two equations: 1/2 r squared theta, which is equal to our area, or our length, which is r theta. So kind of having a quick scan, even just thinking about, okay, what type of topic does this involve, can really help you, break down the question a bit more. Okay, let's begin to read the question. We've got a sector, we've got the area given to us, which is 11 centimeters squared, and the angle AOB is theta radians. Okay, it says that given that the perimeter of the sector is 4 times the length of the arc AB, okay, find the exact value of r. So I'm going to put this as r theta for AB. It says the perimeter of the sector, which is going to be 2r plus r theta, is equal to 4 times by the arc AB. We can start to work out some stuff now. So we know that 2r plus r theta is equal to 4r theta. That means that 2r is equal to 3r theta. That means that 2 is equal to 3 theta. That means that 2 over 3 must equal to theta. And remember, this is in terms of radians. Okay. We also have our formula for our area that we put down before. 1/2 r squared theta is equal to 11. We can start to work out some stuff now, actually. But we're trying to work out the exact value of r. So that means that r squared theta is equal to 22. So I've just multiplied both sides by 2. So I'm going to substitute theta in. So I end up with 2/3 r squared is equal to 22. And I'm going to do 22 divided by 2/3 just to get rid of that coefficient. 22 divided by 2 over 3. And we can do that, by the way. If you want to times by 3 divided by 2, that also works. But we end up with r squared is equal to 33. That means that r must be equal to root 33. We do not include the negative part in this case. Like, I know if you square root, you can end up with a negative, but you can't really have a negative side. So we only say that r is equal to root 33. Cool. Next question. The curve, we've got an ln graph, and we also have y equals x, and it meets at a single point, alpha. Okay. X is equal to alpha. Figure 2 shows a graph of y equals ln 2x, 2 ln 8 minus x, and then y equals x. Okay, and we use an iteration formula. Use a graph Oh, I completely skipped part A even. Okay. Next question. The curve with equation y equals 2 ln 8 minus x meets the line y equals x at a single point, x is equal to alpha. Okay. And it says that show that the root lies between 3 and 4. Okay. So what I'm actually going to do is, when we have an intersection point between these two, or between any two kind of equations, we're going to equate the two equations, right? So we have 2 ln 8 minus x, and we won't go ahead and solve this, but essentially we're going to equate them for now. So 2 ln 8 minus x is equal to x. Therefore, if I move everything to one side, 2 ln 8 minus x is equal to 0. And what we can do with that information is essentially kind of treat this as a new equation, because this is the equation to say, okay, whatever this equation looks like, whether it looks like this, whether it looks like that, it doesn't matter what the equation looks like, as long as it has a root at a single point that represents this solution here. Okay, so essentially what we're trying to do is, even we can get rid of this equal to 0 because technically we don't need it, but what we can treat this as, we can treat it as a new equation. Now it says show that it's between 3 and 4, so we're going to sub in f of 3, and we're going to sub in 4 as well into f of 4, and see what those two numbers give us. So into our calculator, I'm going to type in 2 ln, I'm going to put it like this actually, so it just becomes easier to type. If you have this calculator, great. If you don't, you're just going to have to type it manually, which is fine as well. I'm going to put a minus answer minus answer. The reason why I'm doing that is because I have 3 here, and I can just change it a bit more easier later on. That'll give me 0.219. Okay, is equal to 0.219. Now here, for the next one, for f is 4, this is equal to minus 1.227. Now essentially, it's because the way the root works, this equation here represents the intersection equation between these two graphs. Okay, and you having a root of this graph represents you having the solution, like I said earlier. And because these two values here, one is positive and one is negative, essentially you are saying within these two intervals there lies a number between 3 and 4. Maybe it might be 3.5, maybe, I don't know, 3.7, we don't know at the moment, but within this region we will have a number such that, I'm going to say f of y or f of k, we'll get a number which is equal to 0. And if it's equal to 0, like we figured out earlier here, that's essentially the solution to the graph here. Does that make sense? But because we don't know, we can just say solution will lie between graph, and we need to say this little statement as well. There's a change of sign between f of 3 and f of 4. Okay, and as function is continuous. Continuous essentially means that there's no kind of gaps. Non-continuous graphs kind of includes your tan graphs that kind of look like this, where because you have asymptotes in between, you kind of your reciprocal graphs, that kind of stuff. Okay, those talk about your non-continuous graphs. This graph is continuous, and as your function is continuous, we're going to say root exists between the interval, in the interval 3 alpha, 3 is less than alpha, which is less than 4. Okay, for part B of this question, it says that we are using this iteration formula here, and we need to find an approximation for alpha. Now it says using the graph and starting with x1 is equal to 4. We need to determine whether the iteration formula can be used to find the approximation or not. And it's a 2 marker. Okay, so it hasn't really it says using the graph specifically. Okay, so that really kind of hints to you that you're not using your Newton-Raphson's method here. Rather, you're going to be using, well, one of two. Either it's called the staircase diagram, or it's going to be the cobweb diagram. Now, it really depends on the graph and what type of diagram you end up with. You can't really force it. The reason being, it's really about where your initial x value is going to start. But a good rule to follow is this: curve to line. Because the way that these questions work is you will always have a curve and you always have a y equals x line. Okay, so we're going to use this rule to see what we end up with. So I'm going to draw a straight line up to the curve. Cool. And then we're going to draw to the straight line. I'm going to zoom in slightly so you guys can see a bit better. I'm going to keep on following this rule. Curve to line, then back to the curve, then back to the line, back to the curve, back to the line, and you can see it's starting to get smaller and smaller. And you can see this type of graph will be called your cobweb. So you have two types. You have staircases where it would diverge, and you also have a cobweb diagram. So your part B, because your cobweb is going inwards, is spiraling inwards, we will have a convergence of the root. So it is suitable. The approximation would be suitable. Next question. Question 5. Well, we've got some trig here. And it says, given that we have a y is equal to this equation here, we need to work out what dy by d theta is. Okay. We're probably going to be using quotient rule here. Now, just by looking at the denominator, I'm just thinking, is there any way to kind of maybe simplify this a bit more? Potentially. Maybe combining into a cos formula, but I think that might take a while. So I think going about the quotient rule method might be a bit better. So using the quotient rule formula, this is the way I like to write it, but there is different ways of writing this. F prime g, which these are two functions. So f prime being the derivative of f of x minus fg prime over g squared. It's more or less the same thing as the one that you're given in the formula book. I think it's just a bit easier to write down in comparison to like dv over dx and stuff like that. Okay, so I'm going to call my two functions f prime, g, and g prime, and this essentially is the derivative of f over g. Okay, it's a derivative of your of this fraction here. So our numerator in this case would be 3 sine theta, and our denominator in this case would be 2 sine theta plus 2 cos theta. Well, we need to think about what these differentiate to. Well, 3 sine theta differentiates to 3 cos theta. Make sure you are confident in terms of differentiation in terms of trig. If you're unsure, sine theta goes to cos theta goes to minus sine theta goes to minus cos theta. If you're unsure on how to remember this, a good way that I kind of made up was thinking about the unit circle. Your sine theta is related to your y-axis, and your cos theta is related to your x-axis. And you can kind of think of it like this as well, and differentiation would be going into anti-clockwise, and integration would obviously be backwards. That's one way of thinking about it. That's just I think it's a nice way of remembering it, but make sure you get that down. Okay, and same thing we're going to do here. This will go to 2 cos theta minus 2 sine theta. Cool. Now we're going to substitute into our formula. So f prime and g, we're going to multiply these together. So this becomes the following. 3 cos theta, I'm going to keep it in brackets for now, and we'll expand out in a bit, minus, these will be multiplied, 3 sine theta, 2 cos theta minus 2 sine theta, all divided by our denominator, which is 2 sine theta plus 2 cos theta all squared. Okay, because that's g squared. I don't like this orange now, you know what, I'm going to change this color here. Let's go back to black. Okay. let's begin to simplify this a bit more. 6 sine theta cos theta plus 6 cos squared theta. Now we have to be careful of our minus here. So this will be minus 6 sine theta cos theta plus 6 sine squared theta. Okay, cool. We have a cancellation in there somewhere. And we also have our formula being used. I'm going to go back up to the question. You can see here it says 1 plus sine 2 theta. So I'm going to expand this denominator out. Now if you're uncomfortable with kind of doing the expansion in your head, I like to use the grid method to expand it out. So this is the same thing as 2 sine theta plus 2 cos theta times by 2 sine theta plus 2 cos theta. And now this is the grid method. Essentially just makes it really clear. I think for double brackets is okay, but when you get to triple brackets, I think it can make your life a lot more easier. We can see here 2 times 2 gives you 4, sine theta times cos theta is just sine theta cos theta, and this will be 4 cos squared theta. So that gives us 4 sine squared theta plus 8 sine theta cos theta. Make sure you add the two terms together here. Okay, plus 4 cos squared theta. Okay, let's start to simplify this. You can see that these two end up cancelling out. On the numerator we have the following: 6 sine squared theta plus 6 cos squared theta. Well, that's an identity, so that's just going to be 6. On the denominator we also have the same thing here: 4 sine squared theta plus 4 cos squared theta. That gives you 4. And you can see here we're using some sort of identity. And well, this is probably going to convert to your identity of sine 2 theta in some way. Well, you need to know your identity of sine 2 theta. Sine 2 theta, you can derive it using your formula book, but that will give you 2 sine theta cos theta. Okay, but as you can see, in the denominator we actually have 8. So what do we do to get 8 sine theta cos theta? We need to essentially just times this by 4, so we end up with the following. Cool. Now in the question you can see that this only is it's just a 1 in both of the coefficients. So I'm going to factorize out of 4, and we might actually have a fraction or a decimal in the numerator, which is fine. So we're going to have 6 divided by 4, 1 plus sine 2 theta. Okay, and this will just be the same thing as on the numerator 6 over 4. You can move that up, and you can even simplify this down to 3 over 2, or leave it as 1.5. Okay, and that would be your final answer. Let's look at question 6 here. We've got circle C with center A with the coordinates 7, 5. The line L with the equation y equals 2x plus 1 is a tangent to C at the point P, as shown in figure 3. Okay, so we've got a tangent here, and we need to show that the equation of PA, which is this, is equal to 2y plus x equals 17. Okay, I think a good place to start is just putting down the coordinates. Do we have the radius? We do not. Okay, what else can we do? Okay, it tells us that this equation is 2x plus 1. Alright, so that means that when it's a tangent, when it's PA, well this is going to be radius, right? When you have a radius to the tangent, this will always be 90 degrees. And that means that PA must be perpendicular to L. That means our gradient of PA must be the negative reciprocal of this. So for part A, gradient is your negative reciprocal. Therefore, we have m as our gradient. It's going to be minus a half. So I'm going to do the following: y is equal to negative x plus c. Well, we know that on this line, we have a coordinate that lies on that line, which is 7, 5. So I'm going to sub in 7, 5 into here. So we end up with the following: 5 is equal to minus a half times by 7 plus c. I'm going to work out what plus c would be. So this will be 5 is equal to minus 7 over 2 plus c. Therefore c is going to equal to, if you just put this into a calculator, 5 plus 7 over 2, which is 17 over 2. Okay, that's starting to look good. So I'm going to rewrite this original equation as y is equal to minus half x plus 17 over 2. Multiply everything by 2, so this gives us 2y minus x plus, 2y is equal to minus x plus 17. That means that 2y plus x is equal to 17. Very nice. Part B, what can we work out? Well, we need to work out the equation of C. Well, we know the center point. The only thing we're missing essentially is the radius. And well, we've got now the equation, but we need to work out the radius here. What we can do is essentially work out this coordinate here by working out the intersection. We already have this coordinate, and then we can work out the magnitude of PA. Okay, and that will be our radius. So we've got 2y plus x is equal to 17. Cool. That's our line here. By equating our 2x plus 1, we can work out this intersection point, so we can work out P. So we have y is equal to 2x plus 1. Now this is essentially simultaneous equations. If you want to equate this equation here, you can, but what I'm going to do is actually sub this into this one here, because we've already got kind of a nice form. So I'm going to do 2 times by 2x plus 1 plus x is equal to 17. So I've just subbed this into there. That gives me the following: 4x plus 2 plus x is equal to 17. That means that 5x plus 2 is equal to 17. 5x is equal to 15. And that means that x is equal to 3. Okay, we've just simplified this down. Just make sure your rearranging is very accurate. Now we know that x is equal to 3. Let's work out what the y coordinate would be. Well, the y coordinate, we could just rearrange this equation, I guess. So the y would be 17 minus x all over 2. And if you sub into any formula here, you should get with the same y coordinate anyways. And that should be 17 minus 3 all over 2, which is 14 over 2, which is 7. So that means our p coordinate here is going to be 3, 7. Perfect. Now we have P, now we have A. We can do some Pythagoras to work out what the length of, or what the magnitude of PA is going to be. Well, the magnitude of PA is going to be 7 minus 5. So we're going to do our change in y-axis and change in x-axis. 7 minus 5 all squared. We're going to do 3 minus 7 all squared. Okay, so this is your Pythagoras. And we're going to square root. And if we just put this into our calculator, square root of, I'm going to simplify this just to make it a bit more easy. Just type into the calculator. You should end up with 2 root 5. And I know I put 4 squared, and here is minus 4. It doesn't really matter because it's the same thing anyways. But we end up with 2 root 5. That's our magnitude of PA. Cool. Now we need to work out the equation of the circle. Well, the equation of the circle, we already have the center coordinate, which is 7, 5. So that means x minus, I'm going to actually not write it there, let's write it below. X minus 7 all squared plus y minus 5 all squared is equal to 2 root 5 all squared. Well, 2 root 5 all squared is the same thing as 2 times 2, which is 4, root 5 times root 5, which is just 5. That's going to equal to 20. And that should be your equation of the circle. Okay, for part C, it says that the line with equation 2x plus k, where k is not equal to 1, is also a tangent. So, realistically, just by looking at the graph, I think it's probably going to be around here somewhere. But we need to work what that would be. We need to work out what that essentially would be. Okay. There could be different ways of doing this. We can potentially use the discriminant method. I think a lot of students would probably do that. Well, if you think about what this kind of the differences between the coordinates, what's happening in terms of the x and y coordinates from this p value here, Well, we can see that P is 3,7. We already worked this out. And since the tangent is going to be here visually, we can see that we can apply that same kind of logic to work out what that coordinate intersection would be here. Well, to go from 3 to 7, well, we're adding 4. To go from 7 to 5, we're minusing 2. Okay, so that means our coordinate, our new intersection coordinate here would be, our x coordinate would be adding 4, so that's going to be 11, and our y coordinate would be subtracting 2, so that would be 11, 3. And since we know it's already 2x plus k, we can kind of use y equals mx plus c here, or this equation that they've already given us, okay, and just sub this in and work out k. And I'm going to prove to you using the discriminant method in a second, and you can skip to the next question if you understand what I've done. But 3 is equal to 2 times by 11 plus k. That means that 3 is equal to 22 plus k. Therefore, k is equal to minus 19. Okay, and you can use the discriminant method as well. But essentially, I will go over what I've kind of done here to work out k so quickly, is that because the tangent has the same gradient, right? Essentially, this line here gets shifted across. So that means the only place where the tangent could be is here, right? And because of the way that the circle and the radius works, you can essentially just go down from that coordinates, because the main reason is because we have the same gradient. That's essentially the main reason. Okay, we've added 4 with the x-axis, and we've subtracted 2 with the y-axis, and we've ended up with 11, 3 as our new intersection point. Okay, but if you don't believe me that k is minus 19 using this method, I'm also going to show you using the discriminant method. Okay, using the discriminant method, what we're going to do is substitute this into the circle here, and we're going to end up with 2 coordinates. Okay, so we have x minus 7 all squared, plus I'm going to substitute this into here, so I end up with 2x plus k minus 5 all squared is equal to 20. And we're going to expand this out, and this is where your grid method is going to come really, really handy. This is going to equal to x squared minus 14x plus 49. That's a simple expansion. Now this expansion here might be a bit more tricky, so to stay accurate with your expansion, this is what you're going to use. 2xk minus 5. This will expand out to 4x squared, 2xk minus 10x, and this will be kind of symmetrical down here. K squared in the center, minus 5k on these 2 bits, and then 25 in that bottom right corner. And we're going to write this down and simplify as we go. So we have 4x squared. This will simplify to 4xk. Then the next bit here, I'm going to write this as minus 20x for now, just keep the x's together. And then we have our constant here, which is going to be plus k squared minus 10k plus 25 is equal to 20. And you can see that's a lot going on right now, and we'll start to clean it up a bit. Okay, let's combine all the x squared, so we end up with 5x squared. Let's combine all the x's together. Let me do that in a different color. That's going to be, let's do that in blue. So this is going to be plus 4xk minus 34x. Okay, I'll leave it like that for now. And then we're going to combine all our constants as well. And I'm also going to bring this 20 to the left hand side. So this is going to be plus k squared minus 10k. I have 25 and 49. Actually, no, let's do 25 minus 20 first. So 25 minus 20, that's going to be positive 5. And 49 plus 49 plus 5 is going to give you 54. Let's just double check in the calculator. 49 plus 25 minus 20 does give you 54. Okay, and this will equal to 0. Cool. Now next step, what we're going to do is factorize out the x's. And essentially what we're trying to do is we're going to apply the discriminant on this. There should be a square there. We're going to apply discriminant on this, and then we're going to do bigger than 0. Are we going to do bigger than 0? No, we're not. We're going to do equal to 0 because there's just one solution. It's a tangent. There's only one solution. So before we do that, we need to factorize out this x. So I'm going to factorize this out to 5x squared. This becomes 4k minus 34x, like so. And I'm going to keep the constant there. Okay, and if I compare this to my b squared plus 4ac, or even actually, let's compare this to our ax squared plus bx plus c, you can see that this is going to be a constant. That whole thing is going to be a constant. This coefficient is going to be b, and that 5 is going to be a. So if I substitute this into my discriminant, where it needs to be equal to 0, why does it need to be equal to 0? Because these two are tangents with one solution. We should end up with two values, hopefully. And let's work that out. So b squared, that's going to give us 4k minus 34 all squared. Minus 4, a is 5. C is k squared minus 10k plus 54. And this is going to equal to 0. And we're going to start to solve for k. We're going to expand it out. Let me just double check if I've done everything correctly so far. Yes. Cool. It's always good to double check. Okay. I'm going to expand this out. This gives me 16k squared. I'm going to check my calculator. So this gives me 34 times by 34. That's going to give me 1156 on the end. And then in the middle, I'm going to do 4 times by minus 34 times by 2. That's going to give me minus 272. Okay, this is a nice quick way of expanding out double brackets. This is going to give me minus 20k squared. Minus 20 times by minus 10 gives you plus 200k. And then minus 20 times by 54, I don't know off the top of my head to be honest, 1080. Minus 20 times by 54. Minus 1080, yeah, cool. Is equal to 0. Let's continue to simplify. This gives us minus 4k squared, minus 72k, 2056 plus 76 is equal to 0. I'm going to double check that because I don't trust my own mental maths. 1080. Cool. And then we can actually just put that into a quadratic formula. And it depends really on the question itself. I don't think in this case, because it is a 3 marker, you don't really need to put out the quadratic formula. Sometimes you might need to, sometimes you might not. I think in this case you probably will get away with it if you don't. Minus 4, 72, and 76. That gives me two values where k is 1 and k is negative 19, as we already worked out. And that k is 1 is from the original question where they've given us 2x plus 1, and we already worked out minus 19 here. Okay, you can see the difference in the lengths, and both are valid. And if you do the second method, it's really just important that you make sure your accuracy is there. Otherwise, you can make small mistakes, and that can cost you marks. Question 7. Given that k is a natural number, show that this integral here is independent of k. So essentially, what this is asking us is that when we integrate this integral with the following limits, with the k limits, our final answer will probably not have a k in it, so it just doesn't rely on whatever the value of k is. We will still end up with the same answer. Okay, so you can see that we have a fraction here that we're kind of integrating. So I'm going to use this one here for now, 1 of x, and this is a rule that you need to know, that this integrates to ln x. And obviously integration and differentiation, they're opposite functions. And you can see that ln x differentiates to 1 over x, right? Similarly, if I had ln of x squared, if I were to differentiate this would end up with 2x over x squared. And you can go ahead and simplify that if necessary. But it's important to recognize the laws when we're going ahead and using chain rule on this. And you can use your chain rule, but being able to do it in your head, I think, speeds it up so we can actually recognize what's going on. Okay, so you can see that this x squared, well, the numerator essentially differentiates, and the denominator will just remain whatever argument is in your ln x, in your ln function. And we can use the same kind of rules. We can use the same kind of rules in this integral here. Well, you can see that 3x minus k, well, we don't really have x or anything on the top. So I'm just going to write this as the following. Okay, this integrates to ln of 3x minus k. Make sure you have your absolutes there. However, this is not complete. If we were to go ahead and differentiate this, does this give us this same function again? Well, let's check. Let's just use the rules that we just talked about now. On the numerator, we'll have our differentiating function, because 3x minus k that gets differentiated to 3. And on our denominator, we would have 3x minus k. These are not the same. But how can we adjust this integral such that we end up with 2 on the numerator? Well, we can divide by 3 and then times by 2, which is the same thing as timesing by 3 over 2. You see that? So that means that this integral will be 2 on the numerator. Okay, so that is essentially the answer to this integral. The limits of 3 over 2 ln 3x minus k between k and 3k. That is our integral to part A. If we were to go ahead and substitute some numbers in, or these limits in, we will end up with the following. 3 over 2 ln, we're going to do 3k first, so we end up with 9k minus k, which is just 8k, minus 3 over 2 ln k, so that's going to be 3k minus k, so that's going to be 2k. This will give you 3 over 2 ln, actually, I'm going to write it like this instead. I'm going to factorize out 3 over 2, like so, and this will give me this. And now we can use our log laws, like the following. So 3 over 2, and when we're subtracting, we essentially create a fraction, ln 8k divided by ln 8k over 2k. So this is just going to be 3 over 2 ln of 4. And you can see our final answer doesn't have k in it at all, so it gives us the same answer anyways. So that means no k value, no k in final answer, therefore independent. Okay, very nice. Cool. Part B. Part B says show that this integral is inversely proportional to k. Okay, now this one here you can see that it has squared on it, so I would probably write this as a index form. So I'm going to take a screenshot of this real quick. Let's just move this down. Give me a second. Let's just move this down so you can just see. So I don't have to scroll. I don't have to keep on scrolling back up. Okay. Cool. So for part B, we have the integral of k and 2k, and I'm going to write it like this: 2x minus k to the power of minus 2. Now you can use reverse chain rule here in your head, or we can use substitution with d over dx. I'm going to go ahead and use reverse chain rule, and this is going ahead and thinking about how do the integration and differentiation rules work. Well, if we were to just integrate this like normal, you know, the power increases by 1, right? The power goes ahead and increases by 1. But now I'm going to double check, does this differentiate? Does this function go ahead and differentiate back to this one here? So let's check that. This would go ahead and differentiate to minus 1 times by our function to the power of minus 2. Cool. I'm just going to keep it as a minus. But then we also have to times this by the differentiation of the inside, because that's what chain rule is. And this gives us minus 2x minus k to the power of minus 2. These are not the same, but it's a very, very small difference. And the only difference is the minus, which causes this to become a plus. Okay, so that means that this function here will integrate to this here. And essentially, you can call this integration by recognition. It's a bit of chain rule and a bit of like testing. Okay, how does this relate to this, and how can I essentially change or slightly adjust so I get this part here. Okay, I'm going to sum in the limits. So I end up with the following: minus 2k minus k, which is just minus k, to the power of minus 1. Cool. Minus, and then we have a minus inside as well. here is just going to be, oh, that's wrong, sorry. This should be minus 4k minus k, so that should be minus 3k to the minus 1. Minus 2k minus k, this is k to the minus 1. Cool. This is going to be minus 1 over 3k. Minus that becomes a plus 1 over k. If we do common denominators, this becomes 3 over 3k. This becomes 2 over 3k. And as you can see, this is inversely proportional to 1 over k because it has a constant at the beginning. Therefore, it's just inversely proportional. And that's the final answer. Question 8. We've got a depth of water, and this looks like a trigonometry question. And it says that, well, we've got this equation here, and it's between 0 and 24. Well, just by looking at this, before I even read on, I'm going to assume that this is going to be in degrees. Okay, the reason being, radian is really, really small, so it kind of works between 2 pi, which is, this is like 6.3, I think. And degrees here, this is 24. So if you have loads and loads of revolutions, if you're working with such a small kind of region here, so that's why I've kind of made that assumption, or not even an assumption, a conclusion that this is going to be degrees. And it says that T is the hours after midnight. Okay, cool. It says a boat enters the harbour after 6:30, so this is 6.5, and takes 2 hours to load its cargo, so I'm going to call this 8.5. The boat requires the depth of the water to be at least 3.8 before it can leave the harbour. We'll find the depth of the water when the boat enters the harbour. So it enters the harbour at 6.5, T equals 6.5, and we're just going to substitute that into our calculator. D is equal to 5 plus 2 sine 30 times by 6.5. And if I bring up the calculator, that's going to be 5 plus 2 sine, I am in degrees, which is cool, 30 times 6.5, and that gives us 4.48 meters. Looking at the question, just always just look at the marks as well. It gives you a gauge of the difficulty of how much work you should be putting in. Part B, find to the nearest minute the earliest time the boat can leave the harbour. Okay, so it says the depth of the water needs to be at least 3.8. So I'm going to set the original equation to 3.8, and we're going to essentially rearrange for T. But we need the T value to be within this range here. So I'm going to go ahead and rearrange this. 3.8 minus 5 gives you 1.2, minus 1.2, sorry. And then divide by 2, that gives you minus 0.6 is equal to sine 30t. If we rearrange this, or put this in a calculator even, sine minus 1 of minus 0.6 gives you minus 36.9. Okay, minus 36.89. That's one of our values. 30t is equal to this. But we also have to remember that, look, our limits here, or our argument here is within 30t. So I think it's a good idea to adjust this range to also being within 30t. So this would be 0, I'm going to write the original one, and then 30t would be the following, which is, let me quickly work that out. It's just so that we're able to work out kind of all the different possible values. And it says the earliest time as well, so we'll find out the next one actually. But you can see this one doesn't work because it's negative, and even if you divide by 30 to work out t, it's still going to be negative. But the next value up, if you think about, okay, how do sine graphs work? If I draw the sine graph here, minus 36 is probably somewhere around here. If we were to work out the first possible value, well, we would just do, actually no. If we look at the sine graph, what the sine graph kind of looks like, and minus 36.89 is probably back here somewhere. And if I draw a horizontal line, you can see that the next value up is probably here. Well, how do we get there? Well, essentially, this whole region is 180. We could do 180 plus this number, because you can see this is 36. So this must be 36. I use the idea of symmetry. So we can do 180 plus that number, and that would give us 180 minus, I'm gonna do minus because minus makes a plus answer, and that gives us 216.86. Because it says earliest time, I'm just going to use this first value here. We don't need to work out any more values. So that means that t must equal to, if I divide that answer by 30, and that answer gives us 7.29. Okay. There was something we wrote at the beginning of the question here, 8.5 here. So you can see it takes 2 hours to load the cargo. So we have to actually just take the count of this. So this answer is actually incorrect, because within this time he's still actually loading the cargo. So actually we would actually have to work out another value, which is fine, I guess. So we would be working out this value here, essentially. This value here. How would you work that out? Well, you can see that this is one revolution. One whole revolution is 360. We're going to do 360 minus 36 to work the next value out. And let's pull that up in the calculator. I'm going to get rid of this. I'm also going to get rid of this. Answer plus 360. That's 360 minus the answer. Divide the answer by 30. And that's going to give you 10.77. So that would be our final answer. Let me just write this value down, 323.13. And then that means that t is equal to 10.77. I think looking at this graphically as well, let me pull up the graph for this. Well, you can see this is sine 30x, and then kind of looking at what the answers are. I think having a look at the intersections between, well, you can see this kind of verifies this. And if you have a graphical calculator, this obviously is a lot more helpful. But even kind of looking at the symmetry method here, or if you decide to use a unit circle, that also works. Either way, you should end up with t is equal to 10.77. But we aren't fully done. It says find to the nearest minute the earliest time. So we need to just convert 10.77 to hours. So this will be 10 hours, and if we do 0.77 in our calculator, 0.77 times by 60, 46, you can say 10:46 a.m. 10:46 a.m. Question 9. Now question 9 here is an implicit differentiation question, and we've got an oval looking thing here, and it says that it shows a sketch using this equation, x squared minus 2xy plus 3y squared. So this is going to be an implicit differentiation question, and it wants us to work out dy by dx. Okay, I'm going to rewrite the equation below here just so it's easier to access. Okay, now when we're doing d by dx, what just happened there? D over dx, we would get the following. X squared just differentiates to 2x. Now this part here is actually a product rule, so I'm going to use my formula here, f prime g plus fg prime. It's very similar to, in fact, it's the exact same as the formulas that you use. I just like the kind of function way of doing it because it's easier to remember and it looks nicer. None of the du by dx and all of that. But essentially it's just the two functions differentiated, and it's just that. Okay. I'm going to write f and f prime, g and g prime. In this case, my f is going to be my minus 2x, and my g is going to be just y. F gets differentiated to minus 2, and y gets differentiated to dy by dx. I'm going to do cross multiplication, or you can think of it as substituting into my formula. That's going to be minus 2y minus 2x dy by dx. So that's going to be my product rule. This gets differentiated to plus 6y, but you have to be careful. Whenever you differentiate y, you have to also times it by dy by dx. And then 50 gets differentiated to 0. Cool. Now, because we're trying to make dy by dx, I'm going to move all the dy by dx terms on the other side of the equation. Actually, you know what? Do you want to divide by 2? Let's just divide by 2. Why not? No, we'll do that afterwards. 2x minus 2y is equal to 2x dy by dx minus 6y dy by dx. So I moved all the dy by dx terms to the other side. I'm going to factorize out. So I end up with dy by dx brackets 2x minus 6y. And then I'm going to divide through by this. So I end up with, I'm going to go to the next page, 2x minus 2y all over 2x minus 6y is equal to dy by dx. And then I'm going to divide by 2 because we have a factor of 2. So x minus 3y is equal to dy by dx. Cool. Now in the original question, you see this is y and y minus x and 3y minus x. We've kind of got it the other way around. But essentially, if we take out a factor of minus 1 on the numerator and the denominator, you can see it's the exact same thing. Minus 1 divided by minus 1 is just 1. So we can write it the same way. And this is equal to dy by dx. Amazing. Cool. Part B. It says the curve is used to model a shape of a cycle track. Okay. Measured in kilometers. Points P and Q are the furthest east and west from the origin, and we need to work out the coordinates of P. Okay. Well, you can see here, they're kind of like stationary points almost, but they're not. You can think of them as vertical stationary points. The stationary points will probably be around here and here, where essentially the definition of a stationary point is when your gradient is 0, right? But in this case, your gradient is not 0. As we approach Q, you can see that the tangents, the gradients of the tangents, they continue to increase, and then at Q, the gradient gets really big, and essentially what we call that at these vertical points, your gradient is essentially infinity, right? So as your gradient increases to P and Q, you call them infinite. And essentially, to work this out, we have a dy by dx function here, and we can use that to help us figure out what is infinite. So normally when we're working a stationary point out, we equate the whole thing to 0, we equate the numerator to 0. But hint, you can probably work out what we need to do. We set the denominator to 0 in this case. The reason being is because if I have any fraction and I make my denominator really small, if I just sub it into my calculator here, 1 divided by 0.000001, you can see that's a really big number. Let me make it a bit smaller. As you can see, look, this gets, your fraction will get really big. So that means that as your denominator, I'm going to call this k, as your denominator approaches 0 from the positive side, this will approach to infinity. Okay. The reason why I just put the positive side is because it was from the negative, it would approach negative infinity, but it's still the same concept. So we're going to set 3y minus x is equal to 0. Rearrange this so we get x is equal to 3y. Now what do we do with this information? Essentially, we just plug it back into our original formula here to work out an x coordinate and a y coordinate. So I'm just going to copy this down here, just to make it a bit more easier to substitute in without me scrolling back up. So 3y all squared minus 2 times by 3y times by y plus 3y squared is equal to 50. This becomes 9y squared minus 6y squared plus 3y squared is equal to 50. 9 and 12, 9 and 3 they add up to 12. 12 minus 6 gives you 6y squared is equal to 50. Divide by 6, that gives you 50 over 6, which is 25 over 3. And if we were to square root this, let me just go into my calculator. You can see I kind of did it above, but I didn't like the recording, so I'm just redoing it again. Square root that, we get 5 root 3 over 3. But also we end up with the negative side as well. So y is equal to minus 5 root 3 over 3. Okay. Now, we need to work out this side here. Which one is it going to be? It's going to be your negative 5 root 3 over 3, because it's in the negative y-axis. But it's also in the negative x-axis, so that's also something to take note of.
I'm going to just even get rid of this because we don't need it because it's asking for p. So I'm going to stick with this one here. We know that x is equal to 3y, so that means that x would be just minus 5 root 3. Yeah, and then final coordinate is this. Boom. And that is your final answer. For part C, explain briefly how to find the coordinates of the point that is furthest north. Well, for here, since we set the denominator for to work out the vertical, to work out the horizontal point, if we go back to this part here, this is probably going to be around here, we would work out when the numerator is 0. So for part C, do set y minus x equal to 0, or you can do dy by dx is equal to 0, where y is equal to x. Sub it back into the equation, back into original equation, and then calculate the x and y coordinates via simultaneous equations, because that's essentially what we did through sim-mul equations. Perfect. Question 10. The height above ground, h meters of a passenger, is on a roller coaster. It can be modeled by this differential equation here. And it says t is time in seconds from the start of the ride. And given that the passenger is 5 meters above the ground at the start of the ride, we need to show that this equation, this differential equation can go to this somehow. I think just to start off here, I'm going to put t equals 0 here, so h is equal to 5. I think this will come into handy at some point. And let's start with this. We've got dh over dt, and essentially we're going to rearrange this in a way where we can integrate potentially, because we have a sign here and we need to just get rid of this differential thing. So we have a h. I'm going to move the h to the left hand side of the equation because this is on the numerator, and I'm going to move the t, or all the t stuff, to the right hand side, or keep on the right hand side. So the way I can do that essentially is I'm going to divide both sides by h, so I end up with the following: dh over dt. I have 1 over h here is equal to cos of 0.25t, and I'm going to rewrite this as 1 over 40. You can move the 40 as well to the right, you will still end up with the same answer, but I'm just moving specifically only the h's to the side, and everything else will be t's. And I'm also going to quote unquote multiply up by dt, and essentially what that does is, if I multiply up by dt, this allows it to become an integral. So you have everything in terms of h dh, everything in terms of t dt. I have essentially integrals of these two, and now I can integrate both of these functions. Well, 1 over h integrates to ln of h. I'm not going to add c at the moment, and I'm going to explain why in a second. Cos, if we go back to our kind of list here, cos will integrate back to sine. So I'm going to put sine of, I'm going to put a quarter t here. Okay, and well, when you think about how can we essentially have this coefficient of 1 over 40, well, obviously we can times by 1 over 40, but when you think about, okay, what does this differentiate to? This differentiates to 1 over cos 1 quarter t, but we don't want that, we want 1 over 40, so I'm actually going to put 1 over 10 here. Okay, and you can double check with chain rule, does this function here differentiate to 1 over 40 cos of a quarter t? And it does, so that's our integral, and I'm going to put plus c here. The reason why I didn't put plus c on the left hand side is because if we had a constant here plus t and you subtract it anyways, we will always have a constant on one hand side of the equation. So I'm just putting plus c on the right hand side. It just makes it a lot more simpler. Okay. Cool. We know that when t is 0, h is 5. I'm going to substitute that in. So when t is 0, h is 5. ln of 5 is equal to, well, this is just 0, so this part whole, all of it goes to 0. So this is just going to be C. Cool. So now what we have is the same thing as ln h is equal to 1 over 10 sine of a quarter t plus ln of 5. I'm going to move this ln 5 to the left hand side, so I end up with ln h minus ln 5 is equal to 1/10 sine of a quarter t. I'm going to combine this using log laws, so I end up with ln h over 5 is equal to 1 over 10 sine a quarter t. And then I'm going to use my inverse of ln, which is just exponential, so I'm just going to e everything. So I end up with, well, h over 5. The exponential cancels out the ln because they're inverse functions. So this becomes e to the 1/10 of sine 1/4 t, or 0.5t. And then I'm going to also times by 5. You can see we have a 5 here. That means that h, I'm going to put everything in terms of decimals, just because we've done that, sine of 0.25t. Perfect. That's part A complete. Part B, therefore state the maximum height of the passenger above the ground. Okay, so the way that this works is essentially one, you could think about doing it in terms of the differentiation, but I think that could make it a bit complicated. I think another easier way is just think about how do trig values work. Okay, well, the maximum a sine function can be is, well, 1, and the minimum is going to be -1. Okay, so that's the maximum function, maximum height. Well, if we multiply it by 0.1, okay, well, it just shrinks down to 0.1. That's our maximum. So essentially, what our maximum height will be is the following: h is equal to 5e to the 0.1. Why have I chosen 0.1? Because it's the maximum. It doesn't matter what's on the inside here. It's really thinking about what the limits, what the range is of a sine function, and that really is determined by this coefficient here. Okay, and if I just put this into my calculator, this will give me 5e to the 0.1. That gives me 5.53 meters. Perfect. Part C, the passenger reaches the maximum height for the second time t seconds after the start of the ride. Okay, so what I'm going to do is, essentially what we have here is this part is equal to 1. So we have sine of 0.25t. This is the maximum height, or even we can do it like this: 0.1 of this is equal to 0.1. This is the maximum. Essentially what we're working out is the value of t. That means that sine of 0.25t, and you can see we've kind of shown it here, is equal to 1. That's the maximum height. 0.25t is equal to, now because we're working in terms of graphs and we're working in terms of equations, we should be working in radians. So I'm going to convert this to radians real quick, like so. So 0.25, sine, inverse sine of 1 is just going to give you pi over 2. Cool. But remember, that is the first time. The question is asking for the second time. So I'm just going to quickly draw the graph here again, and you can see we have pi over 2 here, and this one will be 2 pi plus pi over 2 because it's just another revolution. We're adding either 360 degrees or 2 pi, and that's going to be 5 over 2 pi. Yeah, 5 over 2 pi. That's going to be equal to that. And then if we divide by 0.25 into our calculator, 5 over 2 pi divided by 0.25, that gives us 10 pi, which is the same thing as 31.4. Is it in seconds? Is it in minutes? It is in seconds, so that would be our final answer. Perfect. Question 11. Use the binomial expansions to show that this is equal to this, and it's a 6 marker. Okay. I'm going to show you an interesting method on how to do this. I think it's different from the way people normally teach. And I know teachers normally teach you to kind of factorize out some stuff and then use a formula book answer. I'm going to use a slightly different method. But essentially, I'm going to rewrite this in the index form. So this is going to be the same thing as square root of 1 plus 4x divided by the square root of 1 minus x, which is the same thing as 1 plus 4x to the half times by 1 minus x to the minus a half. Okay, and essentially we're going to be doing binomial expansion on both of these and then potentially expanding them out. And you can see that we only have up to x squared terms, so we're going to expand out essentially both of these using up to our x squared terms. Okay, and then doing some multiplication. I'm just going to expand out 1 plus 4x to a half at the moment. Okay, and I'm going to show you how to expand this out. In year 1 binomial, if you had, for example, I'm going to use the same example here, this. You were taught that in your calculator you can just type this out, right? And with ascending powers, and then essentially you're taking away 1 from the power each time, and so on. Okay. Why can't you do that with this? The reason why you can't is because in your calculator it just doesn't let you. Okay. However, you can use a formula. And I'll show you the formula. Essentially, it's very, very similar to the formula book, but I think it just speeds things up in comparison to like factorizing stuff out, and it keeps things clean. So the first one is just going to be a half choose 0, because that's our first term, times by 1 times by 4x, and I'm going to put this down twice until we have our second term. Okay, and I'll show you how to do this. This is going to be ascending powers because we want up to only x squared. Okay. So we're going to leave it like this. Now the power on the 1, but in this case it doesn't really matter, but this is going to be a half. And each time you can see we're adding 1 here, so we're going to subtract 1 each time. Again, it doesn't really matter because 1 to the power of anything is the same thing. But those will be your two powers, a half, minus half, and minus 3 over 2. Okay. And now, the trickier bit will probably be working out these. But I think it's helpful to think about how Pascal's triangle also works. Now Pascal's triangle looks like this, right? And this is just a couple numbers off the top of my head, 10, 5, 1. Okay, and you can see, let's choose, for example, this row here. This is 4 choose something. Now if I choose 4 choose 0, you can see that anything choose 0 is always 1. So having that knowledge can help you save time. Anything choose 0 is just 1. Anything choose 1 will be itself. So 4 choose 1 is equal to 4. 10 choose 1 is equal to 10. N choose 1 is equal to n. So knowing this can really, really help you as well, and we're going to use this for this one here. I'll show you how to do 1 choose 2 in a second. So using that knowledge, we're going to do the following. I'm actually going to bring that back. I'll just keep it in the corner here, just in case if you want to look at that. Okay. So the following, 1 choose 0, we know is just 1, so I'm just going to put 1 here. 1 to the half is just 1. 4x to the 0 is just 1. So this will just give us 1. Cool. Next one, a half choose 1 is just going to be a half. 1 to the power of a half minus a half is a 1. I'm not even going to bother writing 1 because it's the same. And then this is just going to be 4x. And this simplifies to 2x. Cool. Next line. Now this part is a bit more trickier. Now you can kind of develop this, derive this from the formula book itself, but I'll show you where it comes from, and you can skip this part because it's not really necessary. In like a couple seconds ahead. But essentially where it comes from is the following: n factorial over r factorial n minus r factorial. You might recognize this formula. It's essentially the formula for n choose r. And this formula works for every single number, including your fractions and your negative ones. And in this case, you can see that our n is a half and chooses r is 2. And how this works is half times by negative half times by minus 3 over 2, and so on and so on. And you can see this is infinite. And the problem is why your calculator can't do this is because it just works with infinities. But what you can do is by using our formula here, you can start to cancel some stuff out. Well, 2 factorial is just 2 times 1. I'm just going to keep that as 2. Okay. Times by n minus r factorial, which is going to be a half minus 2 factorial, which is the same thing as half times by, that's the same thing as minus 5 over 2. factorial. Minus 3 over 2. So a half minus 2 is the same thing as minus 3 over 2 factorial. So in this case. So what we're going to do is rewrite this as the following. When we have an infinite number of numbers that continue to multiply, right, we can almost just simplify this like so. And I'm going to rewrite this like this. A half times by negative half divided by 2 times by, sorry, I missed this part here, like so. And you can see that this part essentially cancels out. And what we're left with is the following. A half times by negative half over 2 factorial, which is just 2. But I'm going to leave it like this for now. And that's going to be equal to a half choose 2. And you might spot a pattern with this. Essentially, a nicer way of doing this is how many terms you have. For example, a half choose 4. You're just going to put that many terms on the top. So a half times by negative a half times by negative 3 over 2 times by negative 5 over 2. Remember, each time you're subtracting 1. And then on the denominator, you just put this factorial. Okay, now this is essentially the same thing in your formula book. It is also the same thing as what's going on here. It is really up to you how you want to do it. This is how I've kind of learned binomial myself. I'm not really fond of the factorizing method, but they're both valid. So for this one up here, this is going to be a half times by negative a half. If you skipped ahead, we just have 2 terms on the top, like so, and then we just put 2 factorial on the bottom. How do we get the 2 terms? We're just going to subtract 1 from our original number. Okay, times by, well, 1 to the minus 3 over 2 is just 1, and this is going to be 16x squared. Now we can simplify this in our calculator very nicely, but I'm just going to do it here. This will be minus 1 over 8 times by 16x squared, which gives you minus 2x squared. Okay, cool. So this is equal to 1 plus 2x minus 2x squared. And we're going to actually do the same thing for the next one. And I'll quickly do this one as well in front of you using the same method. If you want to pause the video, definitely try this using the same method with 1 minus x to the power of minus a half. 1 minus x to the minus a half. So this will look like the following. Minus a half choose 0, minus a half choose 1, minus a half choose 2, and then the brackets 1, 1, 1, minus x, and minus x. Increasing powers, and then these are decreasing powers. Cool. This is going to be 1. Because this is 1, this is 1, and this is 1. The next one, anything choose 1 is going to be minus a half. So it's going to be minus a half times by 1 times by negative x, which is going to be minus 1 over 2, positive 1 over 2x. And this bit, we're going to quickly work out what minus a half choose 2 is. That's going to be a minus half from the original number here. We're going to subtract 1, and we only want 2 terms on the top. Why do we want 2 terms on the top? Because it says 2. Okay, and then on the denominator, we're going to put 2 factorial. Why? Because it says 2. Okay, and this gives you 3 over 4 over 2 factorial, which is 3 over 8. So this is equal to 3 over 8, and you can put this in your calculator directly as well. It will simplify it. 3 over 8 times by 1 times by x squared. That's going to give you 3 over 8x squared. Okay, and that's our expansion up to our x squared term for that value, for this bracket. Now, for the rest of the question, we have to essentially multiply it together, because you can see here. So what I'm going to do is actually use the grid method from before. And what we're doing is essentially this multiplied by 1 plus a half x plus 3 over 8x squared. That's what we're basically doing. And this is where our grid method will come really, really handy, because we have triple terms. So I'm going to put this on the numerator. Sorry, not on the numerator, on this top bar here. And then on the sidebar, if it decides to cooperate, okay, 1 plus a half x, and then plus 3 over 8x squared. Okay. Oh, there we go. Now, before we start with this, I'm going to draw a grid like so. Sometimes I do this, sometimes you don't have to. But essentially, the reason I've done this is because we don't need all the terms. The reason being, you can see this final expression here just has x squared in this term, so we don't need to multiply everything out. Okay. This makes 1, this makes 2x, and this makes 2x squared. Okay. This makes a half x, and this makes 3 over 8x squared. I've just essentially multiplied, that's what I'm doing. Okay. The bit in the middle here, this makes just x squared. Okay. Now, the next bit, we have to be careful, do we really need it? I'm going to check these parts here, x squared and x. That makes x cubed, I don't need this. This makes x cubed, I don't need this. And the last bit makes x to the 4, I don't need it. Okay, so these are the only bits I care about. And I'm just going to simplify them together. So I end up with 1. This is going to be 2.5, so 5 over 2x. This is going to be minus 2 plus 3 over 8. I don't know what that is off the top of my head. Minus 2 plus 3 over 8. And that gives us minus 13 over 8x squared. Is that the final answer? It's not. Why? I've forgotten the bit in the middle. Oops. So we should also add 1 to that. And that gives us minus 5 over 8x squared. Yep, so these are all x squared terms. So make sure you just add those correctly. Don't make the mistake that I just did now. Perfect. And that's our part A complete. Part B. A student substitutes x equals a half into both sides of the approximation shown in part A in an attempt to find an approximation to root 6. Explain why he should not use half. Okay. Whenever you see something like this, you want to think about what the validity, what the validity is for each of the expressions. And a good way to do this, an easy way to do this, is just think about what's that term there, and put that in an absolute value. So 4x is less than whatever this value is, whether it's negative or positive, doesn't matter, just put that number down. It's less than 1. So x must be less than a quarter. You can do the same thing for both of them, so this would be x is less than 1. But you can see a half is not valid because it's just not within both of these. As x equals a half is bigger than, or you could say a half doesn't fit, or doesn't, I can't think of the word off the top of my head. I'm going to say expression is not valid. Is not valid as x, or the modulus of x should be less than a quarter, and a half is bigger than a quarter. Okay, there we go. I don't know why, just the word just wasn't coming to my head. So I'm just going to put this. Perfect. Part C. Substitute x equals 11 into this, and to obtain an approximation for root 6. So what we're going to do is just put this x equals 1 over 11 into kind of this formula here. So we're going to substitute x equals 11 into kind of both of them and see what's gonna happen. So x equals 11. If we substitute it into this, let's check, do we get root 6 straight away? I'm going to take a screenshot of this to move it down because I don't want to keep on scrolling back up. Let's see. Okay. So we have 1 over 4 over 11 divided by 1 minus 1 over 11 square rooted. I've just put this into here. What does that give us? I don't know. I'm going to avoid the square root just so we end up with a nicer fraction. So 1 plus 4 over 11. And then 1 minus 1 over 11. That gives me 3 over 2. So essentially what we're working out here is the square root of 3 over 2. And we'll worry about how to convert that to root 6 in a second. Okay, so if I put 1 over 11 into this here as well, this expression that we just worked out, let me put 1 over 11 like this. Now in our calculator tells us the following: 5 over 2 answer minus 5 over 8 answer squared. and that gives me 1183 over 968. It's approximately 1183 over 968. Now we need to think about, what do we multiply this by to get to 6? Question 12. The value V pounds of vintage car T years after it was first valued on 1st of January 2001 is modeled by the equation V equals AP to the T. Given that the value of the car was 32,000 on the 1st of January, 2005 even, so this is, I would say this is going to be T equals 4 potentially because it's years, and it says 50,000 on T is, it says on 2012, we'll work out what T is there as well. Find the value of P to 4 decimal places. Okay, so here it says 1st of January, and you can see these are also 1st of January. The only difference here is the years. So the difference is, well, this is going to be T equals 4 because this is T years, and this is going to be T is equal to 11. Okay, so using that, we can kind of just substitute the numbers in. So we have 32,000 is equal to A P to the power of 4, and we also have 50,000 is equal to AP to the power of 11. Now we can do simultaneous equations on this, and I'm actually going to just divide both of these. So I end up with 50 over 32, because you can see all the zeros kind of cancel out. It's equal to P to the power of 11 minus 4 gives you 7. So these essentially get cancelled out. Sorry for any background noise there. And you can see the indices here get subtracted 11 minus 4. That gives you P to the power of 7. Now if you go into our calculator, 7th root of 50 over 32, that gives you 1.07. How many decimal places? 4 decimal places. So 1.0658. 1.0658. Cool. Part II, show that A is approximately 24,800. We're just going to substitute it back into one of the equations. I'm going to pick this equation here on the bottom. We know that 32,000 is the same thing as AP to the power of 4. I'm going to divide by P to the power of 4, so 32,000 divided by P to the power of 4 is equal to A. And into the calculator it goes. 32,000 divided by my answer to the power of 4. And you can see this is approximately 24,800 is equal to 24796, approximately 24,800. Very nice. Okay, part B. With reference to the model, interpret the value of the constant A. So this is our constant A. Usually when you have an exponential graph, essentially what this constant means at the beginning is the amount, or the value when t is equal to 0. So that just means that when t is 0, that's going to be the initial price of the car. Okay, we can check that. V is equal to 24,800. I'm going to put P, let's keep it as P to the power of t. And when t is 0, this just goes to 1. So that means at the start of at 2001, or 1st of January, your price will be 24,800. Part II for part B. The value of the constant P. Okay, so this part here, this P value, because it has an exponential attached to it, essentially what that means is kind of the rate. So it's the rate of increase of the price. And we should probably mention as well, because you can see it's 1.0658. So each year, what's happening is you're increasing the price by about 6.6%. So we can say it's the rate of the increase of the price, and then we can say as well, to be honest, we should probably mention each year. We could probably add 6.6% increase each year. Okay, this each year bit is necessary because there is a exponent on the p-value. Okay, part C, I'm going to take a screenshot of this and let's move this down. It says using the model, find the year during which the value of the car first exceeds 100,000. Okay. So essentially what we're going to be doing is equaling it to 100,000 and rearranging. So this is our equation. This is our equation for our V is equal to 100,000, and we'll be using logs, or you can even use ln if you really want. I'm going to divide through by 24,800, so that gives me 1.0658 to the power of t is equal to 100,000 divided by 24800. That gives me 4.03. And then you can use natural log or you can use log base. What's an easier method? I'm going to use natural log, why not? So what happens is I'm going to ln both sides, and then this t exponent can come down, so this becomes t ln 1.0658, and then I'm just going to divide through like so. There are multiple ways of doing this. You can use logs as well. So this will give me ln of answer, so I'm just going to try to keep it as exact as possible. ln divided by 1.0658, and that gives me 21.88. So t is equal to 21.9. But since it's in years and it says find the year, at the start it's at 2001. We're going to add 21 years, so that's going to be 2022. Question 13. We have an integration question here, and just by looking at it, we can't really do any sort of chain rule in this. We're probably going to have to use some integration by substitution. So I'm going to quickly rewrite the integral again, and what I'm going to make as my substitution is this bit in x plus 2. So I have u is equal to x plus 2. I'm also going to change the limits while I'm at it. So my limits here is 0 and 2. If I substitute them into here, 0 plus 2 gives me 2, and 2 plus 2 gives me 4, so that's going to be my lower and my upper limit. So I'm going to write my new limits as 2 and 4. Whenever you make a substitution, you should differentiate that substitution as soon as you can. So you get du over dx is equal to 1, therefore du must equal to dx. I'm also going to rearrange for x, because you can see we have an x term here, and this doesn't exactly match yet, so that means that u minus 2 is equal to x if I just subtract 2 from both sides. Okay, let's start to substitute everything in to my, and this should be dx here as well. Let's start to substitute everything in, so we have everything in terms of u. So this is going to be 2 times by u minus 2, root u du. And I'm going to convert this to into an index form in a second. I'm also going to take this 2 on the outside, just because it can make expanding out a bit more easier potentially. We can move it on the outside or inside at any point. It's just a constant. So this will be u minus 2 times by u to the half du. I'm going to expand out the brackets. So this becomes u to the 3 over 2. And this becomes minus 2u to the half du, and we just integrate. So this becomes u to the 5 over 2, and then we need to divide by 5 over 2, so that gives you 2 over 5. I'm going to add 1 to the power here, so this becomes u to the 3 over 2, and then in our calculator we can do minus 2 divided by our power, which is 3 over 2 in this case, and that gives us minus 4 over 3. Cool. We can bring the 2 back. I think I'll leave it on the outside for now. Actually, you know what, let's distribute it, why not? 4 over 5, u to the 5 over 2, minus 8 over 3, u to the 3 over 2. Cool, why not? Let's do that. Okay, now let's start to substitute some numbers in. So, if you go into the next page, I'm just going to copy this across. Now your calculator will be, honestly, your best friend in this. So individually, what you can do is start to substitute the numbers in, and that will give you the following for the first term: to the power of 5 over 2 Okay, this is going to be 128 minus over 5 minus 8 over 3 times by 4 to the power of 3 over 2, and that gives you minus 64 over 3. And then we're going to do the same thing with 2, like so. And I'm going to change the bottom one as well, and you can see this is a lot quicker. The top one will be 16 root 2 over 5. The bottom or the 2 one will also be 16 root 2. Oh, this one's 16 root 2 over 3. Okay, and if we go ahead and combine these, well, 128 over 5 minus 64 over 3 gives you 64 over 15. And then the next part, 16 root 2, just within those brackets. 16, in fact, I'm going to do it like this: 1 over 5 minus 1 over 3. This might be a bit more easier to type. Minus 2, minus 32 root 2, that would be. And then this one will be 16 root 2 over 5 minus 16 root 2 over 3. That gives you minus 32 root 2 over 15. Root 2 over 15. We just have to be careful of the minus there. And because we're adding, this is going to be 64 plus 32 root 2. And then we have a 1 over 15 on the outside, which we can factorize out. But it wants 32 over 15 on the outside, so you know what, let's factorize out the 32 as well. So that's going to be 32 over 15, 2 plus root 2 as your final answer. Very nice. Question 14, we have a parametric equation question. X equals 3 plus 2 sine t, and we've got y equals 4 plus 2 cos 2t. And we want to show that both of these satisfy this equation here. Well, it says y equals, so I think a good place to start is essentially we have the y term here in terms of t. Y is equal to 4 plus 2 cos 2t. And because it's a show that, we should really try to substitute the x into here somehow. Well, we've got a sine t and we've got cos 2t. Let's try to get rid of this problem first. How can we convert the cos 2t into just cos t or sine t? Well, we're going to use one of our identities, and the identity I think I'd probably use is something to do with the sine. There are 3 identities you need to know for cos, which is cos squared t minus sine squared t. Cos 2t is the same thing as 2 cos squared t minus 1, and you also have another one like so. You can learn this first one up here, but learning these two will also be helpful. I think it'll speed it up. But if you don't learn them, you can derive them using your sine squared plus cos squared equals 1. You're kind of just substituting it in, and you will end up with those. Okay. Well, we've got the reason why I'm using the sine is because we have a sine here. So what I'm going to do is we have a 2 cos 2t, so we're just going to multiply this up by 2. So we have 2 minus 4 sine squared t. 2 minus 4 sine squared t. If we simplify this, it's become 6 minus 4 sine squared t. Okay, I'm going to rearrange this such that I get x minus 3 is equal to 2 sine t. Why have I done that? It's because I can take that sine t and kind of substitute it in. What's the linkage between the 2 sine t and 4 sine squared t? Well, you can see these are essentially just squared. So that means that if x minus 3 is equal to 2 sine t, x minus 3 all squared must equal to 4 sine squared t. Therefore, y must equal to 6 minus x minus 3 all squared. Done. Amazing. Part B says sketch the curve. So when we're sketching the curve, it's important to have all your kind of axes, depending on the question really, but it's good to have your axes. Do we have any limits? We do have some limits. So We should probably substitute them in just to check. But part B, our maximum point we know is going to be 6, and that's going to be at x is equal to 3, and your shape will look like a sad face because it's a minus x squared. So it's going to look like this. It's going to be at 3, 6. Okay, I'm going to put in the 0 and 2 pi into these equations. Well, 0 is just 3, and well, 2 pi would also give you 3, and the way I got that was essentially 3 plus sine 0, and make sure you're in radians for this, it's just 3, and 3 plus sine 2 pi is 3. But we need to think about what is the range of values you have of 3 plus 2 sine t, right? So the way that sine works, the way that any sine function works, is that the maximum a sine value has is 1, and the most minimum value a sine has is minus 1. So if we think about this x value here, which is, I'm going to go down here actually, x is equal to 3 plus 2 sine t. Was it plus 2 sine t? Forgot. Yeah, so if it's x is equal to 3 plus 2 sine t, and we know that sine t maximum is 1 and minimum is minus 1, this can give us kind of a range of, well, what's the range of our x values? So I'm going to put in 1 for now. This will give us our most maximum. So x is equal to 3 plus 2, 1, which is the same thing as 5. This is our maximum x value, and our most minimum x value will be, when it's minus 1, 3 plus 2 minus 1, which is just 3 minus 2, gives you 1. So that will give us between this kind of range, and it's probably going to make a quadratic like so. I think it's a good idea to also find out the coordinates of these. We know this is x is equal to 1, and this is x is equal to 5. And we can substitute it into here to quickly work out the y-axis, the y-coordinate, which would be, let's quickly work that out actually. Let me bring that down. If y is equal to 6 minus x minus 3 all squared, let's substitute this in. This gives us 6 minus 1 minus 3 all squared, which is 6 minus 2 all squared, which is 6 minus 4, which is 2. So it's going to be 1, 2. And then the same thing for the other one, 6 minus 5 minus 3 all squared. That gives you 6 minus 2 squared, which is also 2. And you can see it looks kind of symmetrical, so that does make sense. 1, 2, and 5, 2. And that's our part I complete. In terms of the part B, we've essentially kind of looked at it already. Is because this value here, because of the sign, it limits it to the region here. So I will probably make a little sentence for that. Sine t, or we can put it like this: minus 1 is less than sine t, which is less than 1. Or technically, this should even be equal to. Should probably put equal to signs there. Therefore, you're gonna have 2 is less than x, which is less than equal to 5. Or 1 is less than equal to. Therefore, you have 1 which is less than equal to x, which is less than equal to 5. That is your range for your quadratic. For part C, it says the line with the equation x plus y is equal to k intersects C at 2 distinct points. State the range of values of k, writing your answer in set notation. Okay, I'm going to bring this question down as well. And I'm also going to bring the graph down that we drew. So this graph here is going to be handy because I think it's good to see what it looks like visually in terms of what's going on. First thing I'm going to do actually is just rewrite the line equation that they gave us. Oops, supposed to select highlighter. I'm going to rewrite this as y is equal to minus x plus k. So you can see that this has a negative gradient. So our line you can see here is two intersection points, one here and one here. Now you can keep on moving along this line here to the right until there's only one intersection point now, which is here. What is this type of line at that point? Well, it's a tangent. So essentially you have two regions. One, when your line is intersecting 5 and 2, and you have 2 points there. If it's not intersecting 5 and 2, you're only going to have one intersection point. Okay, when it's intersecting 5 and 2, or 5 2, sorry, you have two intersection points here and here, and then when it keeps on going, your limit, your upper limit, it's going to be when it's that tangent to our quadratic. Okay, so that's essentially what we are trying to find out. We can find the first one quite easily, I'd say. So we can just substitute 5 2 into here. So that means that if y is equal to even less, we don't even need to do that actually. We can just do 5 plus 2 is equal to k. So that means that k is equal to 7. That's our first value, or first inequality. K has to be bigger than or equal to 7. That's our first inequality. Okay, that's when your tangent is intersecting 5 2, and it causes those 2 points to be intersecting. Now to work out the tangent, well, how do you work out the tangent? Well, what we can do is, we have a quadratic, we have a straight line graph. What we can do is equate them together and potentially use the discriminant. So our equation, if I go back up, our equation was 6 minus x minus 3 all squared. I'm going to bring this down here, and I'm going to equate this to minus x plus k. And I'm going to expand out. So this gives me 6 minus x squared minus 6x plus 9 is equal to minus x plus k. 6 minus x squared plus 6x minus 9 is equal to minus x plus k. I've just distributed the minus out. Let's make the x squared positive, so I'm just going to move that to the right. X squared minus 6x, x squared minus 7x. 6 minus 9 is minus 3, so that becomes positive 3 on the right. Plus k is equal to 0. Then what we're going to do is use discriminant. B squared minus 4ac is equal to 0. So we're going to have minus 7 all squared minus 4a, which is 1, c is going to be this constant here, is equal to 0. Therefore 49 minus 4k plus 3 is equal to 0. 49 minus 4k minus 12 is equal to 0. 49 minus 12 is going to be 37. Minus 4k is equal to 0. That means that k must equal to 37 over 4, and that's our upper limit, and that's when it's a tangent. But we don't want a tangent, we want everything other than a tangent. So that means that k must be less than 37 over 4. If we combine these together, we end up with a region like so. And we want it in standard, set notation. I believe, yep, set notation. And the way you write that is x is all real. And then we have some curly brackets on the outside. And that is our final answer. And that is the end of this paper. I'll see you next time. Bye bye.